Hi guys, today we're gonna talk about atomic radius, ionization energy, and electronegativity. And if you stay with me to the end of this video, you could find it yourself that which one of these elements has a bigger atomic radius, ionization energy, and electronegativity. Let's do it. Let's start with the atomic radius. As obvious, the atomic radius is the distance between nucleus and the last shell that is occupied with electron. What is important to find the difference between the atomic radius between the elements? Two factors have a major impact on change in atomic radius in periodic table. So when you wanna compare the atomic radius of several elements, at first you have to specify the situation of the elements in the periodic table. 1. Number of shells which occupied by electron. That is exactly the n in electron configuration. 2. Atomic number. What these two notes mean. Note number 1 is about the elements that they are in the same group. So when the elements are in the same group, whatever the period number be bigger, atomic radius will become bigger. But why? Because the period means the last shell is occupied with electron, and whatever the last shell be bigger, atomic radius will become greater. So period means last shell occupied by electron, and it means the atomic radius. They have straight relation with each other. And note number 2 apply to elements in the same period. And as we know, when the electron in the same period, they have same shell, so the number of shells won't be changed. And the only difference between the elements in a shell is their atomic number. Whatever the atomic number be bigger, the number of proton will become bigger, so the nucleus will send more power to the last electron, and the nucleus attract electron shell toward itself more. Now let's find out which one of these elements has a bigger atomic radius. At first we have to find out the situation in periodic table. When we write their condensed electron configuration, we find out all of them will end up with S1. So as we know, when the elements have same valence electron, they are in a same group. But in the same group, we're common in the valence electron. These elements are in the same group, and as we know from the note number 1, when the electrons are in the same group, from up to down, their atomic radius will become bigger because the period or their shell will become bigger. The biggest atomic radius in these 4 elements belongs to rubidium, because rubidium is the period number 5, so it has 5 shells occupied with electron, and its atomic radius is bigger than potassium. It has 4 shells, and it's bigger than sodium, and sodium is bigger than helium. It has only 2 shells that is occupied with electron. It's done. Now let's talk about the ionization energy. At first I have to tell you that ionization energy is energy for getting the furthest and weakest electron in an atom. But why I say the weakest? Because whatever the electron be in a further place from the nucleus, power of proton toward the electron will become less. And separating that electron or the furthest electron from the atom is easier. So whatever the atomic radius be bigger, ionization energy will become lower, because the separate electron from the atom will become easier, because it's the proton that don't let the electron to escape from the atom. So as you see, the ionization energy have a reverse relation with the atomic radius, and wherever the elements have a bigger atomic radius, they have lower ionization energy. So for these elements, the biggest ionization energy will belong to lithium, because lithium has the smallest atomic radius, so it has the biggest ionization energy, because the last shell of lithium that is occupied with electron is so close to nucleus and proton, and separating the last electron from the atom is so hard, so it has a great ionization energy. It's done. too. Now let's talk about the electronegativity. Electronegativity has a straight relation with ionization energy, because the electronegativity energy is the tendency of elements for getting electron, and it has a straight relation with ionization energy and reverse relation with atomic radius, because whatever the atomic radius becomes smaller, nucleus could get electron from the outside of atom easier. For these four elements, the biggest electronegativity will belong to lithium again, because it has the smallest atomic radius, and then sodium, potassium, and rubidium. Now let's see the trend of atomic radius, ionization energy, and electronegativity energy in periodic table. As I told you, from up to down, the atomic radius will be increased because the number of period and shell will increase, so the atomic radius bigger. But from left to right, the atomic radius will become smaller, because when we say from left to right, we are talking about the same period, and same period means the same shell. The same shell, the only change is the atomic number. When the atomic number is bigger, the number of protons will become bigger, and nucleus will become more powerful, so it can drag the last shell toward itself more, and then the atomic radius will become smaller. But ionization energy and electronegativity, that has the reverse relation with atomic radius, from up to down will decrease, and from left to right will increase, because from left to right, when the atomic radius will become smaller, power for getting less electron from the atom will become greater. So the tendency of getting electron from that atom will increase, and it is the electronegativity energy. I will solve more questions for you from the element in periodic table in the next videos. Be your best. Good luck.